Hi everyone. In this video, we're going to talk about how to find standard scores, also called z-scores. So we have a problem here. We've got stats quiz data. We know the stats quiz given was out of 80 points total. The mean on the quiz was 50, and there was a standard deviation for the class of 12. And we're asked to find the z-score for a quiz score of 42 and a quiz score of 68. You'll remember from class that we learned that z-scores are calculated by taking the data value of interest, subtracting the mean, and then dividing by the standard deviation. That same data, or that same formula works both for sample data and for population data. We calculate z-scores the same regardless. In this case, we need to do two different calculations because we were given two different data values. So we were given an x value or a data value of 42. So that's one calculation. And then we were given an x value of 68. So that's a second calculation. For the first, z is equal to the data value, 42, minus our mean divided by our standard deviation. So let's write out what that looks like. I know that my mean, I'm going to assume sample data here and write x bar is 50. I know that my standard deviation is 12. So 42 minus our mean of 50 divided by our standard deviation of 12. For the other data value, we're going to have z equals 68 minus 50 divided by 12. You'll notice the only thing that changes in this formula is the data value, because both of these quiz scores came from the same group that the mean and standard deviation were calculated for. So the mean and standard deviation in this particular problem are the same. These two quiz scores came from the same group. It's just that x value that's changing. If you're doing this on a TI-84, that makes our life a little easier. So I'm going to pull up our TI-84 here and do that calculation. If you're doing it on another calculator, you're going to plug it into your calculator the same way, but the copy paste might work differently. So I'm going to do the 42 first. I do need to put parentheses around the numerator so that my calculator knows to do the subtraction before it does the division. 42 minus 50, that difference divided by 12 gives us negative 0.66666, so negative 2/3. I'm going to write that as a rounded decimal, so negative 0.67, because we traditionally round z-scores to 2 decimal places, regardless of what the data look like. We should expect that it's negative because the data value 42 is less than the mean. And z-scores indicate where we are relative to the mean. So if we're less than the mean, we should get a negative z-score. To calculate the z-score for the x value of 68, since the only number that changes is that first number, I don't want to retype this whole thing. I'm going to press second enter, and that retypes my last entry. Whatever I typed on the last line, that's going to pop back up. But now I can go back and edit it. I'm just going to type right over 42 with 68. So that gives us a decimal of 1.5. So the z-score for a quiz score of 68 is 1.5. You'll notice a couple things. First, you'll notice that it is positive because 68 is bigger than 50. You'll also know that that z-score ignoring sign, is bigger than the z-score for 42. So 68 is further from the mean than 42 is, because 68's z-score is larger, absolute value-wise, than 42's z-score. So 68 is more above average than 42 is below average. All right, so that is how we calculate z-scores. If you have any questions on what you just saw, let me know. Otherwise, I will see you in the next video.